right now, aren't we? How come it's not working? There we go. Recording. So this is going to be an example of a flowchart proof. Flowchart proofs, you're going to see these more often than paragraph proofs. But on your test, you'll have one. You'll have a choice, like either write a paragraph proof or a flowchart proof. But a flowchart proof is kind of a nicer way because you can organize your information. Okay. So I'm using the same process, and I'm using deductive reasoning to look at this, okay? So we're trying to show that SP is congruent to, so usually what I do is I start at the end, right? So we're trying to show that SP is congruent to QR. In order to show that SP is congruent to QR, what would I have to show first? Marissa? Well, yeah, but I would first have to prove some triangles are congruent, right? Okay? So I'm going to look for a way to show that this triangle is congruent to this triangle. They're very nice to me. They already named one of those triangles for me, right? And so I just have to name this triangle probably over here. But I have to figure out a way to do that, and when I figure out a way to do that, I look at what's given to me. Well, it tells me that these two lines are parallel. How do I know that those two lines are parallel?
Because I have a parallel.
Because it's what's given. So the way this works is you write the reason in the little lines, and you write what you know in the boxes. Okay? What else is given to me? What else is given then? That PQ, that's not a P, okay? You also know that PQ, that's a Q, is congruent to SR. And I know that because it's given, okay? P, that's a Q, good enough. So before I can prove a triangle congruent, okay, so I know this, I know these are parallel. What else do I know? If I want to prove this triangle is congruent, who can look up there and see how I can prove those two triangles are congruent? Shayla?
Since SQ is shared between the two.
Very good. So I'm gonna write that. Where does that go in this box? Right? So you could say QS is congruent. It's kind of nitpicky. You should write it in the right order. QS is congruent to SQ because the triangles are kind of oriented like this one and this one, you know. So Q, and how do I know that? It's shared. You can say it's the same side or shared side or something like that. Okay. So I have a side, right? I have another side. What does this give me? Who can tell me what this gives me? This doesn't mean congruent, it means parallel. But if two things are parallel, what does that make congruent, Greg?
It means that those lines means that the angle things are also going to have the opposite interior.
Very good. Okay, so that means that these angles here, this angle here, right, and this angle there are congruent, right?
Yes.
So this angle, I'm going to call that angle RSQ. Angle RSQ. Uh-oh.
Oh, no.
Oh, no. Angle R. Okay. One more try. Angle R.
Something's wrong.
Something's wrong. Let's try that one more. R. Ooh. RSQ. Q. It's okay. RSQ is congruent to?
You're not going to have enough room.
It's okay. You won't have enough room on your paper either.
PQS.
PQS. And because what Greg said, those are alternate interior angles. Okay? Alternate int angles. I mean, what it really means is that if two lines are parallel, then the alternate interior angles are congruent. Okay? That looks like herant. Doesn't that look like herant?
Yes.
Alternate interior angles. Okay? I don't want to erase the whole mess. So that means that triangle PQS is congruent to triangle PQS is congruent to triangle R. Oh, I hate when that happens. congruent to triangle RPQS. How about RSQ? Okay. Why?
SAS conjecture.
SAS conjecture, side angle side, very good. Therefore, once the triangles are congruent, the lines are these pieces. So what goes here? CPCTC, very good. Daniel,
That's Joey.
Joey, sorry. CPCTC, okay? So that's how we do a flowchart proof. Do you understand that?
Yes.
Corresponding parts of congruent triangles are congruent. We learned that the other day. Yes.
So is QS acting as a transfer?
Yeah, QS is very good. Yeah, it's a, QS is a transverse, okay? So, when you are doing one of these flowchart proofs, the most important thing is that you don't start writing like nonsense all over the place, like you don't write like alternate interior angles over here and oh, it's given. You know, you have to show that you're following a deductive argument. Okay, that's why we learned all about deductive reasoning in chapter 2, because when you do a proof, you're using deductive reasoning the whole way. You ready to do another one?
Yes.
Okay, let's do another one, then you're gonna try one. Okay. So let's look at this second one that is on your sheet. I would be filling out these sheets as along with me. Partial. So let's look at this one. Okay. So this is a little bit different in that I don't end up with two pieces congruent to each other. I kind of, here I have two parts of two triangles that are congruent because you want to look at what you're trying to prove, okay? You're trying to prove that KT bisects EKI, and ETI, right? So in order to prove that it bisects those angles, okay, the big angles, what would have to be true about this angle and this angle? Congruent. What would have to be true about this angle and this angle? Congruent, okay? So to simplify things, instead of calling them ETK and ITK, I'm going to call this angle 1, I'm going to call this angle 2, I'm going to call this angle 3, I'm going to call this angle 4, okay? And now I have to, so my kind of way that I'm going to go through this, I'm going to try to prove these two triangles are congruent. Then I can say that these two angles are congruent, which makes this an angle bisector, right? If angle 1 is congruent to angle 2, by definition, this KT would be an angle bisector of that. You understand that?
Yes.
Okay. So let's look at what I'm given. Kite is a kite. How do I know that kite is a kite?
Given.
It's given. Okay, let's change color. I'm tired of this color. Ooh, let's do purple. That's my favorite. Okay, that's given. Given. Is that purple? That's purple. How do I know that KE is congruent to KI?
Given.
That's also given. Okay. What else am I going to use to prove? Wait. So I know that's given. Okay. So, and I'm going to mark up my picture as I go. So I know that KE is congruent to KI. Something being a kite, what else does that tell me that I can use in proving these triangles are congruent other than correct? Sophie?
Segment IT is congruent to
Very,
TE,
very
or
good.
ET.
That IT is congruent to IT is congruent to ET, right? And because it's a kite, right? So IT is congruent to ET because it is a kite. So we call that, anyone know what I could use that reason?
Kite.
Yeah, we'll call it a definition of a kite. Uh-oh. My thing just stopped. Oh no.
Oh no.
Wait, it's gonna come back. There we go. So def of a kite says that it's a figure with two pairs of adjacent congruent sides, okay? So I have two sides. What else can I use in this picture? Charlie knows. What else can I use in this picture? What else can I use? Yep.
Shared side.
Very good. Another shared side. Very good. Okay? So I know that KT, ooh, that's really a mess, isn't it? Okay? KT is congruent to KT, because it's a shared side. Okay? We'll call it shared segment or side. Okay? Triangle KET is congruent to triangle KIT. Okay? KIT because of
Side.
Side. ETK is congruent to ITK because of what goes here? Once I have proven that the triangles are congruent, CP, very good. Who's that?
CPCTC.
Joey. Okay? CPCTC. Right? So this says once I have proven, this means basically once I have proven that the triangles are congruent, that any of their other parts are congruent. So ETK, where's ETK? ETK, which I'm going to call angle 4, is congruent to angle ITK, which is angle 3. Okay? What do you think goes down here?
Angle 1 is congruent to angle.
Very good. And yeah, the other, you could call it very good, Greg. You could call it IKT, but I'm just going to call it angle 1 is congruent to angle 2. And that is also because of CPCTC.
What is the exact letters?
Oh no.
Corresponding parts of congruent triangles are congruent. I posted it on my notes a couple days ago. But CPCTC, corresponding parts, this is why I don't want to write it, because it's kind of long, of congruent triangles are, it's not a conjecture, it's just a thing, okay? C, P, C, T, C. And what goes here? What goes here? What goes here? This, what I'm trying to prove, goes here, right? So now I write that KT, they have good barbecue too, by the way. KT bisects angle EKI and angle ETI. You will have to go outside of the boxes in some cases. Okay, is that horrible?
Yes.
It's kind of horrible, but it's not as horrible as doing a paragraph proof, right? Yes.
Can you
Okay.
choose which one you do?
Not for this assignment, but on a test you can choose. Okay, but you have to have all the parts there. So I'm going to pause for station identification. Hold on a second. First I'm going to bring up the next, because I'm recording, so I have to have a commercial in a minute. So this one, there we go. So this one, I'm going to let you guys, well, I'm going to help you start it, okay? And then let you guys try to finish it up. All right, so this one, ABCD is a parallelogram. You're trying to prove that angle A over here is congruent to angle C over here, right? Oh, very good. Who said that? What goes here? So some things you could do without even thinking about it, right? This is given, right?
Yeah.
What do you think is going to go way over here? What goes here?
A equals angle C.
So always the thing that you're trying to prove, that comes at the end, right? It's all the stuff in the middle that is going to get a little more confusing. So if ABCD is a parallelogram, then AB is parallel to CD, right? What else is parallel?
AB.
Right? So the other two sides are also parallel. AD is parallel to, we'll call it CB, okay? Who can tell me why this is? Same thing, depth of, oh, whoops. It's a depth of parallelogram, parallelogram, and the same reason down here, depth of parallelogram. I'm going to draw a picture of a parallelogram. There. Okay? Depth of parallelogram. So your job right now is to figure out, instead of calling this, giving it a letter, you could call this a number. Okay? Angle 1 and angle 2. So say something about angle 1 and angle 2, and see if you can, and maybe something about angle 3 and angle 4, okay? And see if you could finish this one up, okay? Go ahead, give that a shot. I'm gonna pause for station identification, okay? And get some extra points, okay? Go ahead. Who's gonna finish it?
It's all around.
Wait. Who wants to finish this up? Go ahead, Noah's gonna finish it up.
Oh,
Okay,
Angle 1 is congruent to angle 2.
very good. Angle 1 is congruent to angle 2. Okay, cause of, well, that says angle. Can't read that, can you? Angle 2 cause of
They're alternate interior.
AI, I'm just gonna go like this. Alternate interior angles, okay? Keep going, Noah.
And then DB is congruent to DB.
DB is congruent to DB, very good. I would say just to, some teachers are very nitpicky, but try to name it in the, kind of go in the other direction. BB and BD, same segment, keep going.
And then angle 3 is congruent to angle 4.
Okay, angle 3 is congruent to angle 4. Who else, why is that, Noah?
Because they're alternate.
AIA, okay? Who wants to tell me what goes in this box? Got, Kira.
yeah, Kira.
Kira, sorry,
Triangle
Sophie.
DAB.
Triangle dab.
I called it ADB.
I am so funny, I can't. Triangle dab is congruent to triangle. The dab is congruent to, go in the right order, BCD, okay?
Maybe it's a
Triangle BCD. Why is that, Kira?
Because of ASA.
ASA.
SA.
ASA, right?
Yeah.
And what goes here? CPCTC. CPCTC. So that's what that one looks like, okay? Did you guys follow that? Alternate interior, so I've got two angles, two sets of angles, a side in between them. That's called the angle side angle. Therefore, they're congruent as CPCTC. CPCTC.